Hello and welcome to the Neon Dashboard, a data analysis tool built on the Neon framework, featuring a collection of connected data visualizations. Users can explore and evaluate their data through the distinct views presented by each visualization. These visualizations can be resized and rearranged as desired by hovering over the edge and clicking and dragging, as shown. When first loaded, the dashboard shows a dataset from New York City containing Twitter, weather, and taxi data. At the top of the dashboard you'll find the timeline, which charts the number of tweets for each day across the range of the data available to us. If you'd like to view the data in hours, months, or years, you can change the date granularity in the Timelines option menu. Below the timeline is the Filter Builder, which allows users to set custom filters on the data. We'll talk more about filtering in a moment. Next to them is the Tag Cloud, which lists the top 40 hashtags found in our Twitter data. The larger items at the top appear more frequently. Then you have the map. For the New York City dataset, it displays geolocated tweets, taxi pickups, and taxi drop-offs. The tweets in the map are represented by the green numbered circles. These are called clusters, and they tell you how many tweets are located in that area. Clicking on a cluster triggers a pop-up containing data from all tweets in that cluster. The taxi pickups and drop-offs are displayed as two separate overlapping heat maps. The red areas are the most densely populated, blue are the least, and yellow and green are in the middle. You can pan the map by clicking and dragging with your mouse, and you can zoom in and out using your mouse wheel or the plus and minus button. As you zoom, the clusters and heat maps will change to reflect the new zoom level. If you have trouble examining all of the overlapping data, you can toggle the visibility of each data layer through the Maps Options menu. You can also enable or disable map filtering on individual layers. If you ever get lost or would like to return to the default map view, click the Reset View button. Next is the data table, which contains the raw Twitter data. This is very helpful if you want to read the full text of the tweets. Next you have the line charts, which plot specific attributes of the taxi and weather data over time. For the New York City dataset, there's average number of taxi trips, average trip duration, average trip speed, average temperature, average precipitation, average cloud cover, and average wind speed. Filtering is a core concept in the Neon dashboard. Setting filters through the visualizations will limit the data that is displayed, allowing you to refine your search and identify important aspects of the data for your analysis. Setting a filter in one visualization causes it to update and show only data matching that filter. The same filter also causes other visualizations showing data from the same source to automatically update themselves as well. Let's take a closer look at this behavior through a sample workflow. Say we want to find occurrences of parades. Using the data we have available, the first step would be to look through the Twitter data and find people tweeting about parades they're attending. You can do this with the Filter Builder by creating a filter on tweets whose text contains the word parade. See how the filter has caused the visualizations containing Twitter data, the timeline, tag cloud, map, and data table to update and show only tweets about parades. Looking at the timeline, each spike in the number of tweets likely represents the day of a parade. Clicking on a bar will set a date filter for that day and update the data in all of the visualizations. Notice that another timeline appeared after you set the date filter. This focus timeline shows only the data within your date filter, so it's easier for you to see. You could have also set a filter by clicking on the Date Filter button, selecting the start and end date in the calendar, and clicking the Save button. From the Tag Cloud and the data table, we see that many people are tweeting on this day about the St. Patrick's Day parade. We can find the location of the parade on the map by searching for the area of Manhattan with the largest cluster of tweets. Then we can set a map filter on that area by holding Shift, clicking, and dragging a bounding box around the area. Now say we want to analyze the trips of taxis traveling to the parade. We'll need to enable the map filter setting for the taxi drop-offs so the locations are limited to the inside of our bounding box. Since we don't care if the taxi started outside our bounding box, we want to disable the map filter setting for the taxi pickups. Now we can zoom out and examine the heat maps for all the taxi trips that ended near the parade on that day. Furthermore, we can analyze the number, speed, and duration of these taxi trips through the taxi line charts. Since we filtered on a single day, we'll only see a single point in each line chart for that day. We can find the number, duration, and speed for taxi trips on that day by hovering over the point in each line chart and reading the value in the tooltips. Let's record these values so we can compare them to the values across the entire date range. To do this, remove the date filter by clicking the red X button in the filter notification in any line chart or in the timeline. Please note that the filters in the filter builder and the map will remain active until we choose to remove them through those specific visualizations. Looking at the taxi line charts again, we can find the value for the day of the parade and compare it with the expected bounds across the entire date range. Since the values for each attribute fall within the normal oscillations of the data, it does not appear that the parade had any impact on taxi trips in the area. Now say we want to identify popular parades that occurred on rainy days. We can do this by comparing the Twitter spikes in the timeline with the data in the precipitation line chart. To make it easier to do this comparison, we can move the line chart up next to the timeline by clicking, dragging, and scrolling using the mouse wheel, and then we can enlarge it, like so. We could hover over the Twitter spikes and try to find one that has a high amount of precipitation, or vice versa. You may be asked questions concerning Twitter, weather, crime, and transportation data from Boston or Washington, D.C. as well. To view dashboards for these datasets, click on the button in the top left corner of the navigation bar and select the desired dataset. If you'd like to read our user guide or watch this video again, you can access them through the Help menu in the navigation bar. Finally, if you'd like to learn more about Neon or contact us, please visit neonframework.org. Thank you and good luck.